All right, back for more. Thanks for joining me, guys, again, guys and girls. Sorry. This panel is going to be about sequencers for rollups. So sequencers, they order and accept transactions from rollup users and post them to underlying layers. A lot more technical nuance. We'll get into that again as well. And I have with me here founders and contributors to the top, shared sequencing networks that are able to service multiple rollups simultaneously. So I'd love to just get started if everybody could do a quick round of intros, and then we'll dive into the questions.
Keep it quick. I'm Josh, founder, CEO of Astria. We're building a shared sequencer primarily focused on Celestia's network.
I'm Bowen, co-founder of Fairblock. We're mainly focused on pre-execution privacy and sort of conditional decryption, but shared sequencing is like an application that we're working on or exploring as well.
I'm Ben. I'm one of the co-founders and the CEO of Espresso Systems. We are a shared decentralized sequencing layer for Ethereum rollups.
Hi, I'm AJ, founder of Radius. We are building shared sequencing layer mainly for MEV resistancy with encrypted mempool and ZK.
Thanks, guys. So to get us started, I want to talk about why decentralizing sequencers. Today in practice, every sequencer on mainnet, or almost everyone I believe, is a centralized implementation. What are some of the things that can go wrong with a centralized sequencer, and why decentralize them? Starting with you, Josh.
Yeah, I guess it's like the kind of immediate bear case of like you're running a centralized sequencer, you get a letter from like a 3 or 4 letter agency, and they say like, hey, don't do that, stop that, turn that off. Now your rollup is turned off. As Patrick on an earlier panel mentioned, right? The point of like a rollup is that you have this kind of escape hatch or whatever, so you can at least like retrieve your funds in that case. But like fundamentally, like the rollup doesn't really exist anymore in like the current development if like the sequencer goes away. So kind of the point of like decentralization of blockchain generally, a rollup in this specific case, is to kind of have this increased censorship resistance from we would generally assume the state is the kind of like strongest adversarial model there.
I guess I'll go. One of the problems is like censorship. So sequencer can just choose not to include your transaction, and that's like poor UX for regular users. The other side is like front running. So a sequencer can sort of insert their transactions ahead of you and sort of see what's going on and take advantage of that.
Building off those, so censorship and liveness are pretty related. Two different aspects of availability and liveness. So that is definitely one of the concerns, but there's actually safety concerns as well with centralized sequencers. And the reason is that users are not waiting for finality from Ethereum. They're not waiting for finality from the L1. One of the reasons why centralized sequencers are nice for users is that they can give instant, fast confirmation of transaction, that transaction inclusion. And users use that as confirmation, and then the payment is considered done, and somebody could ship the goods. Well, you're trusting the centralized sequencer in that case for finality, and if the centralized sequencer decides, oh, well, I actually forgot about the fact that I told you this thing was final, and there's no record of it anywhere, and here's what the actual state is, then it could actually steal funds from users. It could actually not necessarily steal things that are locked in a bridge on Ethereum, but it can reverse transactions that were previously thought of as final, and that enables double spending. And then there's also the monopolization element with pricing. So that's related to front running, but even more general, a sequencer has a monopoly and can decide how to manipulate prices to maximize its revenue, which is exactly what we try to get around in systems like Ethereum. Ethereum is built to have prices find an equilibrium around where demand meets supply, and not what maximizes the revenue of the blockchain. And that is lost if you move to centralized sequencing.
Yeah, from the perspective of security, it might be okay with centralized sequencers because the security is inherited from the Ethereums. But the problem with these centralized sequencers is that they have too many rights, too many responsibilities, like receiving and verify and execute transactions, and also making some generating proof for the rollups as well. So, which leads to like too much power on them. So, decentralization of sequencers might help to address these kind of issues like censorship and single point of failure, those kind of things. But from our perspective, there's only one thing that this decentralized cannot solve is MEV problem. So that's why we Radius is using encrypted mempool to solve this MEV problem, and then like I say this. We want to not only decentralize the sequences, but also empower the power that the the centralized sequences has. So we make sure that there's no harmful MEV, and also we want to make sure that this make these role networks sustainable in economical way.
Thanks, everyone. We're going to dive into MEV a little bit later on, but I think I want to cue it up by explaining how shared sequencers can both, service a singular rollup, or sequencers can service a singular rollup or multiple rollups at the same time. So you have both MEV within one rollup or between rollups as well. So I want to talk about the composability benefits that shared sequencers can enable. And starting with you, Ben, I know you've thought about this a lot. How close can we get to atomic composability with shared sequencers between rollups? What are the limitations and considerations around that?
Good question. So the fact that you're still not sharing the same execution environment puts fundamental limitations on the interoperability that you have. I mean, there's clear benefits from not sharing the same execution environment, and that gives you better scalability. But you cannot make function calls from one contract on one rollup to another if they're not in the same execution environment. What you can do is you can guarantee atomic inclusion of transactions. So if I'm a user and I want to make sure that my transaction on Optimism and my transaction on Arbitrum get included simultaneously or not at all, and included in the order, right? And Optimism and Arbitrum are sharing a common sequencing layer, then I can, as a user, get that guarantee. Now, it doesn't guarantee something over the joint execution of those two. They're individually sequenced in the Arbitrum chain and the Optimism chain, but I can get a guarantee of atomic inclusion, and that may be good enough for users who know exactly what's going to happen with their transaction. Now, there's something that's very nice that comes out of this, which is so important for the ecosystem today. A lot happens at the builder level, right? Flashbots, for example, plays a very, very important role in the blockchain ecosystem. For example, they promise users that they won't pay for failed transactions, and they use their position as a builder and their trust relationship with the user to guarantee that. Say a builder in an ecosystem with a shared sequencer between rollups like Optimism and Arbitrum wants to make a similar promise to users that their arbitrage pair of transactions will succeed, or that they can facilitate some kind of flash loan across different rollups, or any kind of composability that they may want. The builder can not make that promise to users today without assuming a huge amount of risk that they'll submit this as a suggestion to the two different rollups, and one of them will reject it and the other one will accept. But with shared sequencing, a super block for all the rollups is essentially auctioned off simultaneously to the builders. So now the builder that gets to produce the simultaneous block for all these rollups can make this promise to users, and that enables this tremendous amount of power at the builder level, where we have competing builders building different trust relationships with users. They may be able to use crypto-economic incentives as well or crypto-economic bonds to facilitate that trust. The design space is very, very wide open there.
Anyone else want to jump in on that?
Yeah, I guess I think the key thing that's just like a useful point of what is the strict limitation or the trade-off you're making when you lose execution guarantees is fundamentally one of we'll say capital efficiency. So you can't have a flash loan between these, and the point of a flash loan is you have a very, very high kind of capital efficiency. You can borrow a large quantity of capital for a very, very low bond, or it's function like a zero bond. In this, to Ben's point, right, we can use crypto economic primitives in these builders, but fundamentally you still need assets to be between both chains for this builder to provide essentially a loan into these blocks. So you do lose some capital efficiency, but beyond that, I think the guarantees you're able to get with atomic inclusion via a shared builder market are very, very close to what you're getting on a singular L1 today.
Yeah. the rollup-centric Ethereum is kind of usually criticized because there's a lack of composability and liquidity fragmentation. But I think that shared sequence layer is well positioned to solve this problem properly. So and then I can say this shared sequencing layer has usually this shared sequencing layer is kind of stateless, which means that they don't execute transactions, but only to make some confirm the order of transactions. So this sequencing layer, we need to keep in mind that this atomic composability is different from atomic inclusion, because this shared sequencing layer can make sure that to include a set of transactions in multiple rollups, but it cannot guarantee that the execution. We cannot guarantee execution the set of transactions, because transactions might fail or reverts when executing those transactions. So I think Radius's approach is kind of help this out, because we split our blocks into two space. The top of the block includes transactions from encrypted mempool, which we cannot manipulate the order. But the second part, at the bottom of the block, after decrypting the encrypted mempool's transactions, we will publish this one to like a public marketplace for traders or MEV searchers to make good MEV to append these transactions to the block. So at that time, these external builders or external MEV searchers can execute those transactions, and then can distinguish the transactions in the top of the block is going to be reverts or executed successfully. So what I'm saying is that we can provide atomic composability, but there are a lot to be carefully handled.
Thanks, guys. I want to understand a little bit more about maybe the limitations or how far the composability can go between different kinds of rollups. So as you mentioned a little bit before, that there's the criticism that with the Ethereum-centric rollup ecosystems, we're kind of creating these like siloed sub-ecosystems. So like there's the ZK sync ecosystem over here, Polygon over here, etc. Would a shared sequencer network like the ones that you're building be easy, or how difficult would it be? How difficult would it be to connect some of these disparate ecosystems? Is it fundamentally not possible to do so? Or can you connect rollups in different ecosystems using one shared sequencer layer?
Well,
in the Ethereum context, sorry.
I think that's what we're saying here, essentially, which is that you get a lot of the composability that you have by sharing an execution environment, by sharing a sequencer via builders. And it enables a market of builders that can provide virtually all the same types of composability that you enjoy and shared liquidity that you enjoy on Ethereum in now a rollup-centric Ethereum. And that is enabled by having the rollups share a common layer for sequencing.
Thank you. Sorry, I totally missed that. Makes a lot of sense.
I think expanding on that a little bit, and it's unclear kind of like what the exact scoping we want to limit this to, but if we think about like cross ecosystems, I think, referring to kind of the cosmos, the interchain, whatever we want to call it, right? There's kind of two distinct ways we've seen bridging happen. We see like execution layer based bridging, and this is where you have an EVM chain to an EVM chain, and each chain knows how to like verify or like check like a state transition for like the other chain. This is kind of how like rollups in like Eastland work, right? You have like an EVM based L2, and the L1 has like a means of verifying like the state transition of the L2. Between kind of Cosmos, which has these heterogeneous kind of state machines where the Cosmos SDK is used to build kind of whatever state machine you want. They use like a consensus layer bridge, and so there are some like complexities in this when we think about how to do this interoperability, wherein it's like you do need some means for the builder to be able to potentially like simulate, execute whatever to give these guarantees across like heterogeneous state machines, but that's like kind of like very like long tail from where we're at as like an ecosystem right now.
Yeah, to add to that, I think shared sequencing should focus primarily on sequencing. That's hence the name. and that focuses on like inclusion and at a very basic level, implementation of a shared sequencer. You can handle arbitrary data for arbitrary chains. When you get to a more like builder environment, a lot more work comes into like simulating the execution of all of these different chains, so that would make things more complex. But at a very basic level, there shouldn't be any issues with interoperability in terms of inclusion. It's where in execution is when the difficulties come in.
Thanks for that. So much to learn, honestly. Never ends. All right, I want to jump over to MEV, which we touched on a little bit before. Many of you are thinking about solutions that protect against harmful MEV, protecting users, and I know you all have kind of different approaches to that. So I'd love to hear first from you, Bowen. How are you approaching fair ordering and making MEV not as extractive for users?
Yeah, we're primarily focused on like pre-execution privacy, which means that users typically encrypt their transaction in some way, and once that's been committed in some ordering, the contents are sort of decrypted and sent over to a DA layer for execution later on. We also explored like top-of-block auctions and some sort of hybrid approach where users can sort of choose whether or not they want to encrypt their transaction, and this allows sort of searchers and builders to sort of auction for a top-of-block and generate bundles that they would like to be included for enabling good MEV, which is like arbitrage, keeping markets efficient, liquidations, that sort of thing.
AJ, do you want to touch on how your approach might differ?
Yeah. From the perspective of regulation, to remove this harmful MEV is really important. So I think it's quite simple because MEV happens because all transactions are transparent and public to anyone. So until confirming the order of transactions, we need to hide the contents of the transactions from the external attackers like MEV searchers or traders. So that's why we applied encrypted mempool. But the problem challenging with this encrypted mempool is that we don't want to put additional like a trust assumption or dependency on any third-party committees. So that's why we are using the cryptographic primitive called delay encryption. So it works like trustlessly. So any entity can decrypt transactions by solving the time lock puzzles, which leads to a delay on decrypting side. So yeah, and then additionally, we don't see that we usually define the harmful MEV when these MEV transactions leads to financial losses on user side. So, but I think there is a good ones as well. So it's the good ones really important for rollup network because these rollup network needs to find some alternative way to make some kind of a profit to make these networks sustainable in an economical way. So that's how we see this MEV space.
And diving a little more into MEV and how the rollup developers as well as the shared sequencing networks can all get along and profit from it. What are your guys' thoughts on like how to share MEV or even just fees between the developer and the shared sequencer network? Ben, let's start with you.
So the question is, how does shared MEV work? Yeah. So first of all, just following up from this topic of there are different approaches to addressing MEV. Well, different rollups that are running on a shared sequencer may have different approaches that they want to take, that they favor for MEV. Some rollups may favor an auction for their users that runs similar to the proposer builder auctions that happen today. Others may prefer to have a threshold encryption assumption, which makes a very different assumption, which is that an honest majority of some set of nodes are honest, right? That is not the same trust assumption that one has when just using Ethereum. Others may be okay with some kind of delay encryption assumption where the assumption is different because the consensus protocol can stall the liveness of the system and wait for the transactions to be decryptable, and so you have to assume that they have a sufficient incentive to not delay. There's so many different policies. I haven't even gotten into Time Boost, which Espresso Systems is building together with Off-Chain Labs. But the main thing for us at Espresso Systems building a shared sequencer is to build it in a way that's agnostic to how different rollups want to implement their ordering policies. So we don't see transaction ordering policies and MEV mechanisms as something that needs to be implemented at the sequencer level. We build the sequencer similar to the way Ethereum works today, with a very bare bones proposer builder separation, and you can always add on these MEV prevention, protection, or even efficiency auction mechanisms at the builder level, and allow rollups to opt into choosing what they want to do.
Awesome. Anyone else want to touch on that? I know we're running out of time, so any closing thoughts as well would be greatly appreciated.
Sure, I have one. Like I said earlier, we're focused on auctions for top of block that generates some sort of MEV for the shared sequencing layer. But then also in protocol, depending on the rollup, you can sort of have your own MEV solutions. So this MEV pie sort of gets split amongst either rollups, the sequencing layer, and then also fees from users who are covering this, right? But I think we mainly want to provide a better UX for users and more users, more fees. That sort of is a more sustainable sort of way of thinking. Yeah.
I think the main takeaway from this panel is that the design space is just huge. There's so many things you can decide upon, and again, like the last panel, it's gonna be really interesting to see what you guys all build and what direction you guys all go, and having this talk again in about 5 years, what it's really going to turn out. Question from the audience? Is that yeah, you can ask a question.
Hi, I'm sorry, I don't know if I should ask a question,
All
but
good.
I'm just really curious. So, what I understood is that, yeah, as long as rollups use some same sequencer technology, it will provide some cross-chain interaction, atomic transactions for users, which is good. But at the same time, basically, there are 4 people who represent different companies working on different sequencer technologies. So my kind of question is, how do any of you envision the future? Is it there will be some one standard? I guess no, or there will be many, and people will then start solving problem on how to connect those many sequencers to allow this cross-chain transactions, or rollups will eventually support many different the most popular sequencers specifically to allow this service for users to do the atomic cross rollup transaction. So
Great
yeah,
question.
I hope that was clear enough.
Sure, yeah, I can take that. And then, so this is all about network effects, and I think that sequencers are very analogous to L1s in terms of their network effects. I think there are going to be hundreds or even thousands of rollups. There are not going to be that many shared sequencers. There will be a handful, just like there are a handful of blockchains, L1s, that are actually used today. But we don't have only one L1, right? We have multiple L1s. And yeah, so sequencers play a very similar role to L1s.
Yeah, I guess building on that, right? I view sequencers as kind of a back end. It's where the first point of settlement occurs, and the first point where you have some useful definition of finality or inclusion and ordering of a transaction. And when we think about the MEV supply chain and I like the concept of aggregation theory. Aggregation theory usually implies that there's a lot of control closer to the user. So at the wallet level or the routing level, if we a Li-Fi or Uniswap or whatever, you can introduce as many layers of abstraction as you want. And if you look at the MEV supply chain and how it works, there are quite a few layers right now for matching. I'm a user, I go hit Li-Fi routes to potentially other routing protocols. All of these layers can happen. Fundamentally, the sequencer is kind of this layer that might run some auction or a top of block auction, or it may be doing some kind of shielded transaction ordering or whatever, but it's relatively in the back end, and so you can have layers of abstraction for users way closer to them and any in between. Really a little bit early and unclear on how many layers are going to kind of exist here. But I don't think shared sequencers strictly block that. They just give more composability between entities kind of at that layer together.
I think also to add, rollups eventually would like a choice, right? there might be rollups who don't need top-of-block auctions, or there might be rollups who don't need threshold encryption or encrypted mempools, right? It all depends on sort of the rollups use case, and we're providing different solutions to sort of, I guess, different target audiences for rollups. And eventually, hopefully, that will be like flexible enough for anyone to sort of build their own rollup, and they would have a shared sequencer that they can pick from and have it off the bat.
I don't see that shared sequencing layer is kind of a winner-takes-all area, because as Bowen mentioned that not all rollups needs kind of an encrypted mempool for their MAV resistancy. So at the time, like a GameFi might not need those kind of features. So at that time, GameFi choose the Espresso and Astral thing, but some kind of DeFi which might care about this MAV space, MAV thing, they can choose like Radius or Fairblock. So yeah, that's what we see.
Well, thanks so much, guys. That was a great question. So thanks so much for asking it. Yeah.
What's that? Oh yeah, of course. Yeah, thank
For
you.
sure. Thank you so much. And again, thank you guys so much for being on the panel and everyone for joining. Have a great day, and I think we'll talk probably with next year, and we'll have a lot more to talk about. So thank you so much.